Hello students, welcome back. So in this part, we'll discuss about the basic terms used in this topic of solutions. So we'll discuss about what is a solute, what is a solvent and what is solution. We'll also discuss about different combinations of solutions which is possible because of different nature of a solute and solvent. So let's start our part. So our next part, introduction to the solutions. Basic terms. So what are the basic terms used in this chapter? So first basic term is solution. What is a solution? A solution is nothing but a homogeneous mixture containing particles the size of a typical ion or covalent molecule. So generally the size of a typical ion or covalent molecule is around 0.1 to 2 nanometers in diameter. So solution is a mixture of such particles of this size of 0.1 to 2 nanometers in diameter. Next important term is colloid. A colloid is a homogeneous mixture containing particles with diameters in the range of 2 to 500 nanometer. Generally, the difference between solution and colloid is the size of the particle. In solution, the size of the particles is around 0.1 to 2 nanometers. Here it is 2 to 500 nanometers. Next important term is suspensions. So what is a suspension? Suspensions are mixtures with even large particles, right? So in suspensions, the particles have a size greater than the size of the colloids. The important point you have to understand about suspensions is they are not considered as a true solutions. Suspensions are not considered as true solutions. Why? Because they separate upon standing. So generally you will find such suspensions in a river, right? If you consider the rock particles, they are having large size, and when you take a mixture of water with such particles, these particles generally separate. But that won't happen in solution and colloid. In solution and colloid, the particles are, you can't judge whether these particles are separated or not, unlike in suspensions. So this is the important point. So they separate upon standing. The particles which we are discussing about, they separate upon standing in suspensions. Next, solute. So when I'm talking about the particles or when I'm talking about the ions, so there might be some particles, right? So these particles constitute solute. So solute is nothing but the dissolved substance in a given solution. So for example, I take sugar plus water. So when I mix it, I will get a sugar solution or sugar syrup. So what happens is these particles are very small. These particles very small to detect, right? So these dotted particles are the solute particles, right? So here the sugar is called as solute, which is a dissolved substance in a given solution. So sugar plus water, if it gives a sugar syrup, so that sugar syrup is now the solution, right? So sugar is a dissolved substance, so sugar is a solute here. So what is a solvent now? Solvent here is the major component in a given solution. If you consider any solution, for example, here the solution is a sugar syrup, here the solvent is the water, because it is a major component in the given solution. So remember always that solvent will be existing in major quantity than the solute. Next important term, what is a saturated solution? Now you know that a solution consists of a solute and a solvent, right? And finally this solute plus solvent gives rise to a solution. Now what is when you will call this solution as a saturated? When you will call this given solution as a saturated? You will call the given solution as a saturated when no additional solute can be dissolved at a particular temperature. So if there comes a situation in which no further solute or no additional solute can be dissolved in this solvent or can be dissolved in the given resultant solution. So such solution is called a saturated solution. Next term, a supersaturated solution. So when you will call this solution as a supersaturated, you will call this solution as a supersaturated when more than equilibrium amount of solute is dissolved at an elevated temperature. So if the solute suppose is x grams, and if the solution has a capacity to undertake or to get dissolved with the solute with the amount greater than x grams, greater than x grams, if y is that amount which is greater than x, where y is the amount of the solution which can be dissolved in the given solution. So here the solution is now has the capacity to bear more number of particles than the previous number of particles of x grams. So that solution which has such capacity to dissolve more amount of solute is said to be a supersaturated solution. Next, unsaturated solution. So unsaturated solution is found when more of the solute can be dissolved in a particular temperature. The difference is that in an unsaturated solution, more of the solute can be dissolved at a particular temperature, right? So the difference between supersaturated and unsaturated is that here it happens only at an elevated temperature, but in unsaturated solution it is happening at any particular temperature. So that is the important difference between a supersaturated solution and unsaturated solution. Another important point in supersaturated solution is that in a supersaturated solution, like it should be slowly cooled, right? More amount of solute is dissolved at a particular temperature, right? And then the supersaturated solution is slowly cooled. Next important basic term. So when you know that there is a solute, there is a solvent, there is a solute, there is a solvent to give a resultant solution. This solute might be anything. This solute might be existing in any phase. What are the different phases possible? Solid, liquid and a gas. So these are the three different phases which can be possible for any given substance. For example, you have water. So for water, the liquid phase is water itself. The solid phase is ice and the gaseous phase is vapor. So any given substance can exist in three phases, right? So any substance thus can be having a solute phase of three types, that is liquid, right? So solute. So solute can be a gas, solute can be liquid and solute can be a solid. Similarly with the solvent, right? So the principle applies for the solvent also. So for the solvent, there can be a liquid phase, there can be a solid phase and there can be a gaseous phase. So similarly, the resultant solution may also have a gaseous phase, a liquid phase or a solid phase, right? Now there can be different types of solutions because of different permutations and combinations of solid liquid gas of solute, solid liquid gas of solvent, right? So for example, when you consider the solute as a gas and that solute is dissolved in a solvent which is also gas, right? Then what happens is the resultant solution is also gas. For example, oxygen, right? Oxygen is present in lower quantities in the atmosphere or in the air, right? But nitrogen is present in the higher quantities. So oxygen here is the solute, nitrogen here is the solvent, right? And the resultant mixture which is called air is also a gas. So here the solute oxygen is gas, solvent nitrogen is a gas and the resultant solution is also gas. So next, when you consider a solute as a gas and solvent as a liquid, what is this situation? Generally, you consider any drink like Pepsi, or you drink like any Coca-Cola, Coke. What is happening in this? Here, the solvent is a liquid, right? Any beverages, you consider any beverages, or you consider even a swimming pool, the solvent is a liquid, right? But the gas is a solute. So, for example, in carbonated beverages, CO2 is a solute, which is a gas, and H2O is a liquid, right? So the resultant solution, for example, Pepsi or a Coke, is also a liquid. So this is one type of solution. So this is the first type of solution which is possible. This is the second type of solution which can be possible. Next, liquid. If the solute is a liquid, solvent is a liquid, the resultant solution is also a liquid. So one of the example is wine, right? Ethanol in H2O. So ethanol is a liquid which is a solute. Water is present in heavy quantities, which is a solvent, and the resultant wine is also a liquid solution. Next, when you have a solute of solid and when you have a solvent of liquid, so that's what sugar in water is a good example. The solute is a solid and the solvent is a liquid, which is water, and the resultant sugar syrup is a solution. So this is the fourth type of the possible solution. So when you have again next a liquid solute and a solid solvent. So this generally is when you consider dentin amalgam for fillings, right? This is also an important example of the given solution where your solute is a liquid but the solvent is a solid. So this is a rare example you will find. Here the liquid mercury is acting as a solute, and solid silver, which is present in very high quantities compared to the liquid mercury, is considered as the solvent, and the resultant solution is also solid, right? So this is the fifth type which is possible. Next, solid in solid. This is a famous example, right? Generally you consider any alloy. For example, here you can consider steel. Steel is an alloy of carbon in iron. So carbon is a solute here and iron is a solvent here. So carbon is present in very less quantities compared to the composition of iron in the given steel, which is a solid, right? So here the solution is a solid itself. So these are the different types of solutions possible when you have a solute in different phase and solvent in different phase. So you will get a resultant solution accordingly, and we have discussed many examples in this different types of solutions. So friends, these are the few basic terms which are used in this concept of solutions. So in the next part, we will move on to the concept of different concentration terms used in solutions. Keep tuned to our sessions. Have a good day. Goodbye.